Hello, welcome to my organic unit ISP. I will be doing functional groups in alcohols in section 1.3. So, to get started, functional groups. A functional group is a special arrangement of atoms that is mainly responsible for the chemical behavior of the compound. Now, they can also be responsible for some of the physical properties as well. When one or more of these functional groups are attached to a compound, this compound is referred to as a hydrocarbon derivative. A hydrocarbon derivative is made up of carbon atoms and at least one other atom that is not hydrogen. Now, here are some of the organic compounds and the functional groups of those compounds that will be commonly used in this unit. You have alcohols, which we'll be focusing on today, haloalkynes, aldehydes, ketones, carboxylic acids, esters, ethers, amines, and amides. Alcohols and their physical properties. Alcohols are hydrocarbon derivatives that contain a hydroxyl group made up of oxygen and hydrogen atoms. Now, since hydroxyl groups are very polar, this makes smaller alcohols, the ones with less hydrocarbons such as methane or butane, a lot more polar as well. This means that when smaller alcohols are placed into water, that means they can dissolve very easily. Now, as the hydrocarbon chain of alcohols get longer, their nonpolar characteristics start to overpower the polarity of the hydroxyl group. So this means alcohols with larger parent alkynes such as octane or heptane will have a harder time dissolving in water than those alcohols with smaller parent alkynes. Toxicity of alcohols. LD50, aka the median lethal dose, is used to find out the short-term poisoning potential of a substance/material. This is done by figuring out the amount of a toxin agent that is needed to kill 50% of a population of animals, such as rats or humans. Now, since this is LD50, not LD100, this means that this is not guaranteed to kill. This means that you could take more of the lethal substance and live, and it is also possible to take less of the lethal substance and end up dying. Now, here are some of their common alcohols and their toxicity order from best to worst from LD50. So you have ethanol, which is the best because it takes the most to kill you at 7,060 milligrams or 7.06 kilograms. And you have ethane-2,2-diol for the worst because it takes the least amount to kill you at 47,000 milligrams or 4.7 kilograms. Naming structural formulas for polyalcohols and alcohols. So the process for naming polyalcohols and alcohols are the same, which they involve 4 steps. An important thing to remember is that alcohols are made up of one hydroxyl group, while polyalcohols have more than one. For example, out of the common alcohols that were given, only ethane-1,2-diol is a polyalcohol because it has 2 hydroxyl groups, which you can see here, while the other 3 are alcohols, where they only have 1 hydroxyl group here, 1 here, and 1 here. A cool fact about ethane-1,2-diol is that its common name is ethylene glycol, and it is the main component of automobile antifreeze. So, the first step in naming alcohols and polyalcohols is identifying the root or the parent alkyne, which is the longest chain of carbons that includes the hydroxyl group. Now, if you were to look at this first carbon, you would notice that there are 2 possible carbon atom chains that you can use. You have this 4 carbon atom chain right here, 1, 2, 3, 4, and the 6th carbon atom chain, which is highlighted. Now, since you want the longest chain of carbons, we're going to use the one that's highlighted. And since there are 6 carbons in that chain, this means the parent alkyne is heptane. And we know this because heptane is made up of 6 carbons, and there are 6 carbons in the chain. The second step in naming alcohols and polyalcohols is identifying the suffix. But before we do that, there is a mini step that you must do in between the first and second step. And that is, you want to number the carbons in your carbon atom chain so that the lowest possible numbers are next to the hydroxyl group. So if you were to look at this compound in the example, you would notice that the hydroxyl group is on the right side, so therefore the carbons would be 6, 5, 4, 3, 2, 1, with the lowest possible numbers being next to the hydroxyl group. So after you have numbered your atoms in your carbon atom chain, you can then identify your suffix. And to do that, you want to look where your hydroxyl group is and which carbon atom it's bonded to in the carbon atom chain. So if we look here, we'll notice that the hydroxyl group is bonded to the first carbon atom in the chain. So therefore, the suffix is going to be -1-all. Now, an important thing to remember with the suffix is that when there is more than one hydroxyl group, such as 2 hydroxyl groups or 3, there's going to be a di or tri in front of this for the corresponding number of hydroxyl groups, such as di for 2 hydroxyl groups, 3 for 3 hydroxyl groups, and tetra for 4 hydroxyl groups. The third step is identifying the prefix. So to do this, you want to look at your compound again and look for which element that is already not being used. So if we look at the compound in the example, you'll notice there are 6 carbons in our chain which is being used, and our hydroxyl group which is being used in the suffix. So therefore, we'll have an extra kind of group of elements right here. So on carbon atom 3, there's a methyl group right here. So the prefix is going to be 3-methyl because there's an extra methyl group attached to carbon atom 3. For the fourth step in naming alcohols, you want to then combine all your steps, which is the root, the prefix, and the suffix to name your compound. So therefore, the name of this alcohol here in our example is going to be 3-methylheptine-1-all. Now, an important thing to remember with the parent alkyne is when the suffix begins with a vowel, we have to omit the E on the end of the parent alkyne. This means alcohols which only have one hydroxyl group will always have to omit the E, and polyalcohols which will always have more than one hydroxyl group don't have to omit the E. So, how to draw polyalcohols and alcohols? The process for drawing alcohols and polyalcohols and alcohols involve 5 steps. For an example, let's do 4-methylpentine-1,2-diol. So the first step is you want to identify the root, which is easy enough, and you want to look at the name that is given and identify the parent alkyne in it. So if we look here, 4-methylpentine, we'll know that the parent alkyne is pentine. And since pentine is made up of 5 carbons, therefore the main chain of the alcohol is going to have 5 carbons. Which leads us into our second step where we want to draw and number the main chain. So therefore we'll have 5 carbons, and then you want to number the main chain from left to right. So 1, 2, 3, 4, 5. The third step in drawing polyalcohols and alcohols is then identifying the suffix. To do this, you once again look at the compound of the name that is given, and you find your parent alkyne, which is pentine, and then look to the right of that, and it'll give you your suffix. So, because the suffix is -1,2-diol, this means there's going to be a hydroxyl group on carbon atoms 1 and 2. We know there's 2 hydroxyl groups because there's a di on the ol, so that means there's 2. And then we can then draw our hydroxyl groups on carbon atoms 1 and 2 here. The fourth step is you want to identify your prefix and then draw the side groups. So once again, look at the compound that was given, the compound name that was given, and then you find your parent alkyne, pentine again, and look to the left of that, and that will give you your prefix. So since the prefix is 4-methyl, this means there's going to be a methyl group on carbon atom 4. Which is right here, which we didn't draw. So the final step in drawing polyalcohols and alcohols, after you have identified your root, your suffix, and your prefix, is you want to add enough hydrogen atoms to give each carbon atom in the carbon chain 4 bonds. So if we look at the compound over here, we'll see that this carbon atom only has 2 bonds, so therefore it's going to get 2 hydrogens. The second carbon in the chain is going to have 3 bonds, so therefore it only gets 1 hydrogen. The third already has 2 bonds, so it'll get 2 hydrogens. The fourth is in the same predicament as the second, in which it has 3 bonds, so it only gets 1 hydrogen. And the fifth carbon atom in the chain only has 1 bond, so therefore it needs 3 hydrogens to get 4 bonds. And therefore 4-methylpentine-1, 2 diol will look like this, fully drawn. So I attached another video which I will lead you through 2 questions for naming alcohols and drawing alcohols, but after that these are some extra questions to help practice, and the answers are on page 752 of your textbook. Thank you for listening to my presentation, and I wish you luck on the rest of the unit.